remember the algebra, it shouldn't be too bad, but a lot of times people don't remember their algebra. If you're in the boat where you don't remember your algebra very well, then you have all week next week that you can practice it. Sound fun? Yes. All right, so what we're going to be talking about here are linear functions. We've already been talking about our linear equations, but we're going to start writing them in what we call function notation, okay? I know you guys have seen this before, but you may or may not remember it, and so that's why I'm here to remind you of such, okay? First thing I'm going to do is I'm going to formally define what a function is. Not ever because you have to regurgitate formulas, but simply because I like to provide definitions of everything that I speak of. So, a function, f, is a rule that assigns to each input, in other words, we usually think of that as each value of x, exactly one output. And you guys usually think of that as a value of y. So each x value that you plug in can go to exactly one y value. It can only go to one place. Okay? So, when we write a function, we can name him any letter we want. We usually call him f of x because f is for function. There's no originality whatsoever in this. Okay? So, you can have all sorts of different types of functions here. And they're really actually a lot of fun to play with. But let's just pretend I have a function of, say, let's keep him pretty simple, x plus 7. This is an actual line. We know that because it's in the form mx plus b. But what I want to do right now is just get you guys used to playing with function notation. So for example, if I want you to compute f of 5, what I'm saying is, you guys, if x is equal to 5, what's my corresponding y value or function value? Well, do you guys agree that I've replaced x with 5 on the left side of my equation? Therefore, fair is fair, I'm going to replace x with 5 on my right side. So isn't that equal to 5 plus 7 or 12? In other words, the ordered pair 5, 12 lives on that line. Are you okay with that? Similarly, you can compute like f of negative 6. Do you agree that's equal to negative 6 plus 7, aka 1? Yeah? Now, what I have over there is different than if I ask you to find, say, where f of x is equal to 5. Do you see how this looks different than finding f of 5? Okay? Because here what I'm saying is I want to replace x with 5. Over here what I'm saying is, hey, take your function f of x. In this case, it's x plus 7, and set it equal to 5. And therefore, we're actually finding our x values. Do you guys agree x is negative 2 in this situation? Do you see the difference here? Okay, so there's a difference between computing f of 3 versus f of x equals 3. Okay, what does f of 3 mean? Again, everywhere where you see an x in your function f, you're going to plug in 3. In this particular function, it's 3 plus 7 or 10. In other words, my ordered pair is 3, 10. You with me here? On the other hand, if we're solving f of x equal to 3, aren't I solving x plus 7 equals 3? So x is negative 4. In other words, my ordered pair here is negative 4, 3. Here you're given your x value and you're finding your y value. Here you were given your y value or your function value, and weren't you finding your x value? You guys with me?
Where did the 7
Oh, I was just using the same function as I had over there. Thank you.
So that will change.
Oh, heck yeah. I want to make it change right now. So I thought I wanted, right? Okay, let's just play with one more function. Now, we're not going to be dealing with quadratic functions in this class. We're only dealing with linear functions. But let's just do one. How about f of x is x squared minus 5? Okay? So let's compute two things and write their corresponding ordered pairs. Let's compute, let me see, f of 11, and then let's compute that. Now we're using this new function. This isn't stuff to stress out about, but I want you guys to understand this notation. It's really important. Okay, what does it mean to compute f of 11? Everywhere where I see an x in my function f, what am I going to plug in? 11. So isn't that equal to 11 squared minus 5? And you get 116. So that's my ordered pair. Right? 11 squared is 121 minus 5 is 116. You guys with me this far? Here, I want to solve where f of x is equal to 11. So what do I do here? I take my function f of x and I set them equal to 11. Can I solve this? Totally. In fact, I intentionally made our numbers really nice for us. How do you solve it? Well, the easiest way, I believe, is you add 5 to both sides. Don't worry if this is all funky to you because you're not doing quadratics in this class. And then, does anyone remember how to get from x squared to x? Square root both sides. And I claim you get positive or negative 4. So here you have 411, and you also have the ordered pair negative 411. So yeah, your function can change. All right, relating that to lines, okay, I'm looking in section 1.3. I'm going to do number 14, and then we're going to talk about 3 specific types of functions that we're looking at here in terms of applications, and then I'll do a few examples, and we'll call that good. Okay? So, what if I want us to find the constants m and b in the linear function f of x equals mx plus b. So f of x and y are the same thing, such that f of 2 is equal to 4, and the line has a slope of negative 1. Well, I claim we're actually given one of these things right from the get-go, aren't we? We are. Okay, we want to find m and b, our slope and our y-intercept. What are we given right from the get-go? Slope. We know, oh, m is negative 1. Right? We're actually literally told that. So do you agree so far? I'll put it as f of x. F of x is negative x plus b. You with me this far? right? Negative 1 times x is negative x. All right, can I find my value of b? Well, we need to ask ourselves, are we given any additional information? Totally! Aren't we given the ordered pair 2, 4? See? Our function value at 2. In other words, when x is equal to 2, our function value is 4. Yeah, nice smile. All right, in other words, when I plug 2 in for x, my function value is 4. Can I solve for b? Totally, what's b equal to? 6. Are you thrilled? I can tell. All right, so we're going to look at 3 types of functions primarily in this section. They're all interrelated, okay? So let's talk about something here. So suppose I have a little business, which I wouldn't, but anyway, suppose I make t-shirts, okay? That's my business. Do you guys agree I've got costs involved with making shirts? With any business you have costs involved, yes? Okay? Now, one comment that I'm going to make to you guys is we're only going to be dealing with linear functions here. We're not going to go beyond that. Okay, so we're kind of like taking it down to the simplest type of function, if you will. Okay? So, do you agree when you have costs involved, you have fixed costs? In other words, you don't have to produce anything, but you still have the costs. For example, if you have to rent a warehouse, you've got rent. Even if you don't make any items, you still have to pay your rent. You still have to pay your electricity. You still have to pay for various things. So there's things called fixed costs. Essentially, fixed costs are the costs of producing no items. Producing 0 items. Does that make sense? Okay? And then I claim that there's also things called variable costs. And that's the cost per unit to make each unit. So then you start involving materials and the like. Okay? So, if we're going to look at our cost function and view it as a linear function, what I want to do is relate it to what we're talking about. We call him C of x because it's our cost function. Our fixed costs, I claim, represent one of our variables here. Okay? Aren't our fixed costs the cost when x is equal to 0? In other words, our cost when producing nothing. If I plug in x equals 0 here, what do I get? B. In other words, your y-intercept represent your fixed costs. So x is the number of units produced. You all agree, if I plug in x equals 0, this term goes away and I'm just left with my b. Any questions here? All right, so if I say, when x is equal to 0, my cost is b. If x is equal to 1, in other words, if I make 1 unit, I still have my fixed costs, but don't I add on my m? Right, because if x is equal to 1, I just have m plus b. If I had x equals 2, wouldn't my cost be b plus 2m? In other words, every time I produce an additional item, isn't it costing me m more dollars? So m is essentially the cost per unit. Sometimes that's written as the production cost. So your M and your B are really significant. Are you guys with me this far? Okay? Now, hopefully, if we have a business, we make money, right? The money we make is called our revenue. Now, let's talk about my t-shirt business. Suppose I charge 10 bucks a t-shirt. If I sell one shirt, how much money do I make? $10. This isn't a trick question. If I sell 2 shirts, how much money do I make? $20. If I sell 7 shirts, how much money do I make? $70. So, if X represents the number of units, and P represents the price at which I sell them at, would you guys grant me that the amount of money I bring in is the price I sell them at, the price per unit times the number of units? Right? If I sold 1 times 10 gave me 10. 2 times 10 gave me 20. 7 times 10 gave me 70. You with me there? Okay, that's another function you gotta know. So R of X is the price per unit sold times the number of units sold. All right, we live in a capitalist society. We care about our profits, don't we? We hope we have profit that's greater than 0. Well, how do you figure out what your profits are? Don't you take all the money you made and subtract off your costs and hope you end up with a positive number? Yes. So, the last one involves your profit. Your profit is equal to your revenue minus your cost. So it's R of X minus C of X. Does that make intuitive sense? And if you don't make and sell enough units, you're going to have negative profit. So that's a bummer. You guys ready? Are there questions this far? All right, let's do this then. I'm going to look at number 12 in your book. And I am going to say this. Suppose a manufacturer has a monthly fixed cost of $100,000 and a production cost of $14 per unit. And suppose the product sells for 20 bucks per unit. Can we write an equation for our cost function? Yes. Okay? These are linear. You guys, what is my value for M here? How much do we charge, or excuse me, how much does it cost us to make each unit? 14x, and what are my fixed costs? 100,000. What's my revenue function? How much do we charge per unit? $20, so isn't it $20 per unit times the number of units? You guys with me? It's kind of a nice little pre-spring break type section, isn't it? All right, what about our profit function? Well, you take your revenue function, watch this though, and you subtract off your entire cost function. In other words, put parentheses around your entire cost function. Well, you can just distribute your negative sign throughout your parentheses. See, if you forgot your parentheses, you would have your negative correctly here, but you would have a plus here. That's not okay. So we have 6x minus 100,000. Are you guys with me this far? All right. So, while we're on the subject here, let me just ask you a few questions, or two questions. What is the profit for producing, how about 15,000 units? Well, again, we have to figure out what we have here. This is my profit function. Do you all agree I'm looking for my profit, my P? Therefore, I better be given the number of units, and aren't we? Yeah. So aren't we really just computing P of 15,000? So we have 6 times 15,000 minus 100,000. And actually, we lose $10,000. You with me here? All right, let me ask you another question pertaining to this. And then I only have 2 more examples. My other question is, do you guys know what it means to break even? Yeah, when you break even, you don't gain and you don't lose. Would you guys grant me that breaking even, boy, we know it's the end of break, I'm out of overheads. Your profit is equal to 0? Yes? All right. And if your profit is equal to your revenue minus your cost, and that's 0, aren't we saying that it is exactly when our revenue is equal to our costs? So, why don't we ask one more not very interesting question here. How many units must be produced and sold in order to break even? All right, well, in order to break even, doesn't that mean that's where our profit is equal to 0? So you take your profit function, set it equal to 0. Is this something we can solve? One hopes. Scoot your 100,000 over. And then divide by 6. And you're going to get X to be 16,666.6 repeating. Since we're talking about the number of units, you would have to round up because 16,666 isn't enough. So this is how many units we would need to produce and sell. Does that make sense? All right. Let me give you another little variation on this theme. On this one, we're only going to find our cost function. And then the last example, we're going to get away from money, and we're going to talk about something I'd rather talk about, crickets. I know you were all guessing that's exactly what I was going to say, right? Okay. So, suppose a company has fixed costs of, I don't know, let's just keep 100,000. That's a nice number to compute with. Further, suppose that it costs $140,000 produce 20, let's do 200 units. Let's find the equation for our cost function. Okay, our cost function is mx plus b. We're not given everything just as nicely here, are we? I claim one of the things we're given. What are we given? We're given our fixed cost. Isn't that our b value? Good job. So, don't we know we have mx plus 100,000? Is everyone with me this far? Yes? Okay. You're all very quiet. I understand it's nice out. You'd rather be out there. 10 more minutes. All right. Now, we need to find our value of m. Are we given more information? Totally. Aren't we given that when we produce 200 units, isn't that my x value? In other words, when x is 200, what are my costs? 140,000. Yes? See how I got that from over here? All right then, can we solve for m? Yes. How do we do it? First you scoot your 100,000 over, so you get 40,000 is equal to 200m. Now what? Divide by 200. If this is funky algebra for you, well, here's something great you can do over break. All right, come on. So what do you get? Oh, that's so cute, 200. So isn't my cost function 200x plus 100,000? What's this 200, the slope, give me? Isn't that the cost to produce each unit? Cool. You guys with me? You're all very quiet. At least nod or shake your head. So, do you have a specific question?
I'm just stretching.
Oh,
Sorry.
no, never apologize for stretching. Cats especially got it right, you know, they know how to stretch. All right. Let's just do one more example. It's going to talk about crickets, though. And this is super duper cool. Okay, this is number 34 in your book in case you care. Not doing the whole thing, but we'll do part of it. It says that entomologists have discovered that a linear relationship exists between the rate of chirping of crickets of a certain species and the air temperature. Isn't that cool? So cool. It says when the temperature is 70 degrees Fahrenheit, they do 120 chirps per minute. And they also tell us when it's 80 degrees Fahrenheit, they do 160 chirps per minute. We're given that this is a linear relationship. So what I want to do is write the number of chirps per minute as a function of the temperature. So, you know, if you walk outside one day and it's 65 degrees, once we find the equation of this line, you'll be able to compute how many chirps per minute this certain species of cricket makes. So, you could say that it's essentially N of T. So T is the temperature. Essentially, that's like our X value. And our function value, the N, is the line, we either need a point and a slope, or we need 2 points. Yes? Okay? I claim we're given 2 ordered pairs. Okay? My t value is my x value. My y value is the number of chirps. So do you guys agree that when it's 70 degrees outside, there's 120 chirps? And when it's 80 degrees outside, there's 160 chirps? You with me this far? If you wouldn't have thought about it, this is why we come to class. All right. Can I find the equation of this line? Yeah, what do I need to do first then? Need to find the slope. Good. The slope is the change in y values over the change in x values. So you're going to get 4. Do you guys all agree? I almost put cost function. That right now we have 4x plus b. I could use n and t, but I think people prefer y and x. You guys with me this far? Can I find my y-intercept? Absolutely. You can either use your y equals mx plus b, or you can use the y minus y1 equals m times x minus x1. This is what we've been doing. It doesn't matter which way you do it. I'll do the y minus y1 version. If you like the y equals mx plus b better, ignore me for a bit. Do it at your seat. We'll see that we get to the same place. So we have y minus 120 is 4 times x minus 70. You guys with me? So we have y minus 120 is 4x minus 280. So you end up with 4x minus 160. Or you could say number of chirps is 4 times the temperature minus 160. Isn't that cute? And this is true. I think that's what the neatest part of the whole thing is. Are there any questions on this? Alrighty then. If lines are funky for you, please do lines over break. Please, please, please practice them, okay? Because we're going to start finding where 2 lines intersect. We're going to be doing a whole bunch of things after break. All right, everyone take out a sheet of paper. I saved my extra credit /pop quizzes for days like when there's about 100 people